if you see this notation here, what does that mean? Very good. That refers to the fifth derivative of x. So if you see that on anything, like I said, that's been a past thing on convention. Don't freak out. That doesn't mean anything but just taking the fifth derivative of the function. Yes.
So in a situation like that, would they give you something that had like x to the sixth?
Well, they don't have to. They could. I remember having a test, and I just second guessed myself into it, but it was something that the last derivative ended up just being the constant that was at the end of the function. And I looked at it and I thought that was the answer. It was like the 20th derivative, but I still didn't trust myself and I took it all the way out. I got it right, but that was the only problem I finished on the test. No, I'm just kidding about that. Not really, but anyway. So that's just a notation deal. But today, I want us to look at something called integration by parts. And in integration by parts, I want us to consider a product. Let's call this product UV, okay? This product is going to be UV. And UV is going to be a differentiable continuous function. So we're going to take the derivative with respect to x of UV. And the derivative with respect to x of UV would be what? Be careful. All right, it would be the first times the, so it would be u times v prime, right? What next? Plus
v times u prime.
V times u prime, right?
We're not have to put dv dx and then du dx. So we're not doing a lot of integration.
Yeah, I'm combining them both. I'm combining Leibniz with Newton's. Okay, so at this point right here, now let's say, for example, that I want to take the antiderivative of both of these parts. Okay? So I'm going to take the antiderivative of both sides. Okay? The antiderivative of the derivative of uv would be
Just regular.
uv, right? Well, we're going to forget plus. Technically it is, but we're going to forget the plus c for right now.
Well, if you have it on both sides, then the c's will.
Now the c's we can cancel out. That was a good joke. You almost put it off. All right. Now, the antiderivative here would be u dv dx.
So what if they...
No, hold up. I'm doing this wrong. I need to add a step on this side. Let's make this u v prime dx plus the integral of v u prime dx. So uv would equal to the antiderivative of u dv plus the antiderivative of v du. Now, I'm going to just do some arithmetic here And in doing that arithmetic, I'm going to move sides right here. No, I'll take that back. I'm going to move this over to here. So I'm going to have that the antiderivative of u dv will be equal to uv minus v du. Now that's going to be the formula that we're going to look at today. This is going to be my formula for integration by parts. The integral of, write this down. It's written in reverse order, but that was just so I could prove it. The integral of u dv is going to equal to uv minus the integral of v du.
Is it always going to be U V?
No.
You're just using U
I'm just using U's and V's.
The first one at the bottom says